Hi there, Pre-Calc students. Time for another lesson. Today, 1.5, writing equations of parallel and perpendicular lines. This is something, again, that you've seen before, I think, so we should be able to move pretty rapidly through it. Notice this chart here. Just wanted to fill this in and describe the difference between parallel and perpendicular lines. I think most of you are familiar with this, but let's just fill this in anyway. So if we were talking about a definition of a parallel line, of course, we would say that these are lines that never meet. Okay, and of course the slope of parallel lines are the same, and of course that's why they never meet. Now if we talk about perpendicular lines, on the other hand, if we were to look for a definition of those are lines that do cross, they do meet, and when they meet, they cross at a 90-degree angle, which of course you know. Now the one slightly tricky part about perpendicular lines is their slope, and sometimes students tend to get this mixed up a little bit. So the slope of perpendicular lines are obviously not the same. They have to be different in order for there to be an intersection. And their slopes are actually opposite and reciprocals. So opposite reciprocals. So therefore, just to give a quick example how this might work, if you had one line that had a slope of -1/3, the line perpendicular to it, well, we have the opposite, so it'd have to be a positive number, and the reciprocal of -1/3 is 3/1. So those two lines right there would be examples of lines that are perpendicular if they had those slopes. So opposite reciprocals. So we're going to do a couple of problems here. Before we get started, some of you have remarked on these videos you never see me. Maybe that's a good thing. Probably it's a good thing, but just in case you wanted to remember what I look like on these videos here, I Googled. Here are some images that I came up with, and all these have something to do with Plocker or Tom or something like that. And so if you want to picture me as one of these fellows giving you this little presentation, maybe that would be helpful. Let's take a look at a problem here. We want to determine, I'm going to give you a pair of equations of lines here. These are both linear equations. Do you think these are parallel, perpendicular, coinciding, or none of those? Coinciding actually means it's the same line, maybe just written in a little bit different form. So obviously the best thing to do here is to see if we can figure out what the slope is. And of course on this second one here, that slope is pretty easy to figure out. Since this is in slope-intercept form, this slope is -1/2. Now the top one in standard form, that's a little bit trickier to be able to figure out what that slope is. We could always try to get it in that slope-intercept form, so let's try to do that. I'm going to get y by itself, so then I just have to subtract 2x from each side like this. And then I'm just going to divide everything by 4. And I get y equals, well, there's -2/4, which is the same as -1/2 x, plus 4/4 is 1. So now we can make that comparison. We know that this bottom one had a slope of -1/2, and this one also has a slope of -1/2. Now it's possible they could be then either parallel or coinciding. However, we know they are not coinciding because of the different y-intercept. That makes these two unique lines. So therefore our conclusion for this would be that these two are parallel. So that's one type of problem that you'll certainly see in your assignments as you work through those, and just a good one for being able to distinguish the differences between a couple kinds of lines. All right, this problem here, this is again a pretty typical one, and several steps involved here, so it can get a little bit hairy, it seems like. But let's see if we can slog our way through here and see what we can figure out. So ultimately we're going to try to come up with a standard form equation. So that's going to be my final answer. It's going to pass through a particular point, and it's going to be perpendicular to this line. So maybe first thing let's do is let's take a look at this given line and see if we can figure out what the slope is of that. Now, notice that this is in standard form. We could do as we had done on that last slide and try to get it in terms of y, so in that slope-intercept form, and we can easily pick out the slope. But let's just try something a little bit different here. When something is in standard form, which remember is this ax plus by equals c, the slope, anytime you have it in that form, is going to be the opposite of a over b. And there might have been an earlier homework problem that talked about that, I think. That's just a little bit of a shortcut to figure out the slope if a line is in standard form. So if we look at our particular line that we have here, my a value would be 2, my b value is 5, and so the slope in this particular line is going to be the opposite, or negative 2 over 5. So that's the slope of this line. So the slope I actually want in this case, because it is going to be perpendicular, will not be this slope, but will be that opposite or negative reciprocal. So now when I go to write my new line here, I'm going to start out with this point slope that you remember from another lesson. And just to refresh your memory about that, looks like this. And since I do have a particular point, and now I know what kind of slope I'm looking for, I think this will be a good one to go from. So remember the y and the x stay the same here. Now I just fill in the blanks. My y1 is the given point. Now watch out for this. The slope is not negative 2/5, but it's actually positive 5/2. And my x1 is the given point there. Minus a negative 2 is the same as plus 2. There's my equation. Now I just have to clean it up a little bit to get it in standard form. First thing I think I will do is just distribute this 5/2. So 5/2 x plus 10/2. I'm going to multiply everything by 2, I think, just to clear out those fractions. Remember, standard form, no fractions involved there. So 2y minus 20 equals 5x plus 10. Now I just have to rearrange stuff a little bit here. And it looks like my final answer for standard form is going to be 5x minus 2y equals, let's see, negative 30, I think is what I'm going to get. You can double check that. Ran out of room there a bit. But that's my standard form equation. So a number of steps on those. That's what makes those a little bit tricky. We'll keep working on these in class as well. So that's the lesson on parallel and perpendicular lines. We'll see you guys in class.